Okay, so like I said, I'm just gonna do notes up here, and this should just be a review for you. If you have your computers up, you should put your computers down, unless you are typing up notes, which I find it very hard to believe that you are. So this is chapter 2. So we are starting chapter 2. Let me see if I can focus him better. Okay, chapter 2. This chapter is all about, it might take me a minute to adjust this so you guys can see and I'm comfortable. Chapter 2 is all about biochemistry. So biochemistry is going to be the study of the substances and chemical reactions that happen in living things. So it's kind of a tad of chemistry. So biochemistry is the study of the substances and chemical reactions in living things. That's what this chapter is about. Study of the substances and chemical reactions in living things. So this chapter we are going to look at, today we're just going to do a review of the atom and the atomic structure. We're going to look tomorrow at molecules and compounds, and then we're going to look at 4 very important organic compounds that are found in all living things. I'm kind of moving you through the chapter. Then we're going to talk about enzymes, which speed up chemical reactions in living things. So it's very chemistry oriented. So like I said, if you are in physical science recently, it might all come rushing back to you. If you were in physical science in the fall, you might have to delve deep. So the first thing I'm going to start with is an element. And you have a nice big list of elements right in front of you. Periodic table. There are 92 naturally occurring elements on the periodic table. The rest are man-made. Elements are substances composed of all one type of atom. So maybe I can unzoom that a little bit. Too small? Is that okay? Then I might switch it around. I know, technical difficulties. Okay, you'll have to tell me. I can never quite get this right. Okay, so as I was saying, substances composed of all one type of atom. I'm going to switch my orientation of my paper. And I'm going to start. I always have such a hard time with this thing. There we go. Let's start with the atom. Is it upright? Can you see it? Is it big enough? Okay. So, first of all, the atom is the most basic particle of matter. So, most basic unit of matter. That'll be on the board. Let me try this. Guys just have to be patient with me here. technology is not my strong suit. Obviously, I'm sure you guys have noticed that. There we go, that's a little bit better. Most basic unit of matter. Okay, so who remembers what particles, subatomic particles, are found in the atom? Nice. So let's start with protons, neutrons, and electrons. What is the charge on a proton? Positive. And neutrons? Neutral. I'm just going to put a 0 for neutral. And electrons? Negative. Very good. Excellent. So protons and neutrons, where are these guys found inside of the atom? I heard it. They are found inside the nucleus. So the nucleus contains most of all of the mass of the atom. So nucleus, most massive part of atom. So the protons and neutrons, and I'm not going to give you the mass of them, but the protons and neutrons are extremely massive in comparison to the electron. So when we're talking about the mass of the overall atom, it's majority of that mass, I would say 99.9% of that mass comes from the nucleus. The electron, the mass is so tiny, they actually say it's negligible, like it doesn't even matter in regard to the entire mass of the atom. Okay? So where do the electrons reside? You guys remember that? Like where are the electrons found? Awesome. Electron cloud. And anytime I do the E with the little sign, that means an electron. So the electrons are found inside of the electron cloud. So all atoms are electrically neutral. That means, or that the reason they are electrically neutral is because the number of protons equals the number of electrons. So if you know the number of protons, you automatically know the number of electrons. So now I'm going to go to one of those boxes on your periodic table of elements, and I'm going to use carbon as an example, because carbon is the major element that is found in all living things. In the upper left-hand corner, you should have a whole number. You should have an elemental symbol. Sometimes they call it a chemical symbol. And then you have a number down here. Somebody double check, is that right? 0.01017. Am I good or am I off there? For carbon?
0.01.
I have an extra 1 in there. 17, okay. So I'm off just a little bit. Okay. Okay, so like I said, this is considered, I mean, it can be called a chemical symbol or elemental symbol. The symbols usually come from the names of the elements: C, carbon, O, oxygen, N, nitrogen, He, helium. Some of them are a little tricky. So some of them, the elemental symbols do not correspond to the actual element name. Does anybody remember where the symbol comes from if it doesn't match up with the name?
Greek.
Louder?
Greek or Latin?
Latin. Very good. So there are several elements on the periodic table that the symbol does not come directly from the name. It comes from, like Alan said, the Latin name. So like Fe, iron, ferrum is the Latin name. I don't know all of them off the top of my head. W for tungsten is wolfram. Copper, Cu is cuprous. So there's several that don't match the name. Potassium, K. So that's where some of those come from. This whole number right here, does anybody remember what that whole number is called? It's actually on your, good, it's on the periodic table. This is your atomic number, and that tells us the number of what particles? Protons, just protons. Now the thing is this, the atomic number represents protons, okay? If the number of protons changes, the element changes. So the number of protons dictates the type of element you actually have. So anytime that number of protons changes, you're getting a whole different element. If you know the atomic number, then you automatically know the number of electrons because protons are equal to electrons. This guy right here, this guy is called the atomic weight. Is this all coming back to you? Okay, this guy is called the atomic weight. He's sometimes called the average atomic weight. He's sometimes called atomic mass. Sometimes he's called the average atomic mass. Any of those words work, okay? They're all, he's got lots of different names, okay? So what this number tells us, the atomic weight, this is the weighted average of an element's naturally occurring isotopes. The atomic weight is the weighted average of an element's naturally occurring isotopes. So we're going to talk about what isotopes are in just a second, or remind you guys. You would have learned this in physical science already. The atomic weight, it's rarely, I don't want to say ever, it's rarely a whole number because it's taking into account an average of the mass of the different isotopes, okay? So isotopes, I'm going to come over here and define it. Isotopes are atoms of the same element with a different number of, does anybody remember? Yay, neutrons. Isotopes are atoms of the same element with a different number of neutrons. They're the same element, always the same element, because they always have the same protons. The only thing that's different is how many neutrons are present, and then that changes the mass. Because if you think about it, if you're stuffing more stuff inside of the nucleus, it's going to get heavier, okay? So I'm going to stick with carbon, use carbon as an example here. Carbon has 3 isotopes. Carbon 12. Actually, I'm going to write it out this way. Carbon 12. Carbon 13. And can I fit carbon 14? Carbon 14. So carbon has 3 different isotopes. Carbon 12, carbon 13, carbon 14. Okay. This whole number right here, that's attached to the name. Okay. So this whole number, this is called the mass number. Does anybody remember what the mass number is? What 2 particles make up the mass number? Excellent. Ah, Austin, that just warms my heart. Means you were listening last year. Mass number is equal to the number of protons plus the number of neutrons in the nucleus. So just looking at carbon 12, carbon 13, carbon 14, who has the most neutrons? Who do you think has the most neutrons? Each of these have the same number of protons. Each of these guys have 6 protons. So who has the most neutrons? Carbon 12, 13, or carbon 14? 14 does. So we know how to find protons because we just go to the periodic table and go to the atomic number. Okay? We know how to find electrons because if you know the number of protons, it's equal to the number of electrons. This is how you figure out neutrons. Okay? You take your mass number and you have to subtract the number of protons. Okay? 6 protons. That will tell me that carbon 12 has 6 neutrons. Carbon 13, if I subtract my 6 protons, I have 7 neutrons. Carbon 14, if I subtract my 6 protons, I have 8 neutrons. So carbon 14 has the most neutrons, so this guy is going to be the heaviest. Okay? Now, of these 3 isotopes, one of them is most abundant in nature. It means one of them is found in most compounds, in most molecules. It's just around more often than the other 2. And this is how you determine which one is the most abundant or most abundant in nature. You go to your periodic table of elements. I'm going to go back down here. See this number right here, the atomic weight? Let's round this to the nearest whole number. If we round that to the nearest whole number, what do we get? We get 12. When we do that, that tells us which of these 3 isotopes is most popular, okay, or is found most often out in nature, okay? So even though there's only one that's represented on the periodic table, okay, there are more isotopes out there, okay? Some of them are found quite often and is represented on the periodic table. Some, they're hardly found at all, okay? I'll give you just one more example. So we have hydrogen 1, and I'm just using this symbol here. I'll use the name. You have hydrogen 1, hydrogen 2, hydrogen 3. So hydrogen's got 3 different isotopes. So first of all, how many protons does hydrogen have, you guys? 1. So hydrogen 1, if I subtract my 1 proton, how many neutrons does this guy have? He's got 0 neutrons. If I subtract 1 proton here, I have 1 neutron. And if I subtract my 1 proton here, I have 2 neutrons. So who's the heaviest? Hydrogen 1, 2, or 3? 3. Okay. So look on your periodic table again. Find the weight of hydrogen and round that to the nearest whole number. And which one is most abundant in nature? 1, 2, or 3? 1. I think it's 1.0007 something. So that rounds to 1. So hydrogen 1 is the most abundant in nature. And I'll tell you, he's like 99.93% abundant. That means these 2 are rarely found. It means hydrogen 1, the hydrogen atom that has no neutrons, is found in most compounds and molecules. Okay? It's just out there, okay, most popular. The only other thing that I wanted to show you is you can write the symbol for isotopes in a few different ways, okay? You can write, like I showed you, you can write the name like carbon 12. Oh, I know 2 things I want to tell you. You could shorten it up and do the symbol -12. You could also write it with the symbol. You can put the mass number on the top and the atomic number goes on the bottom. And this just represents an isotope. So this number on the top here, this is your mass number, and this number right here, this is your atomic number. Now, if I was to say, I wonder what the mass number of nitrogen on the periodic table is. Okay, so if I wanted to know that, so I would find nitrogen, and if I needed to know the mass number of the isotope on the periodic table that is most abundant in nature, I'm going to find nitrogen. I'm going to go to the atomic weight, find the atomic weight, round it to the nearest whole number, and what is that? That is 14. So the mass number of the isotope of nitrogen on the periodic table is number 14. Okay? And that's just the most abundant. And I think I've covered everything. Questions? That should just really be a very fast review from last year. Yes?
Can you flip it back to the back? I didn't get it. So,
Can you what?
can you flip it back to the back? I didn't manage to get it all down.
I can do that.
Or
That one?
I don't put part of the file cover.
Oh,
Okay.
there you go. Okay, I think I covered everything. So I'm going to give you a little bit of a practice. Let me stop my recording.